All right, so welcome everyone to Math 111 College Algebra. In this lesson, we will be discussing section 1.2, which talks about linear equations and irrational functions. So we shall be going through the objectives, and we hope that by the end of this lesson, we would be able to solve linear equations in one variable, solve linear equations containing fractions. We will also be able to solve rational equations with variables in the denominators. We will look at if there are variables in the denominator, what we need to do, what needs to be excluded from the solution, etc. We will also talk about how to recognize identities, conditional equations, and inconsistent equations. These are different kinds of equations, and we will learn how to distinguish between them. And also we shall discuss an applied problem that uses mathematical modeling. All right, so a linear equation is basically an equation of a straight line, an equation that can be written in the form ax plus b is equal to 0. This a can be any number, and x is the variable, and b can also be any number. And we have a can't be 0, b can be 0, but a can never be 0. So a linear equation basically is an equation that has one variable, either x with a number in front of it plus another number, or just the x with a number in front of it by itself. The x can also be any other variable. It's not exclusive to it. X is not the only variable that can be used. Several other variables. We can use a y, we can use a t, any other variable can be used in place of x. All right, let's move on to the next slide. So generally, the steps that we go through in trying to figure out whether some equations are equivalent is to simplify the expression on one side, group the like terms on one side, add or subtract the real numbers, or multiply or divide by the non-zero quantity on both sides of the equation, and interchange the two sides of the equation. So these are some of the steps that we shall see shortly through an example, how we implement some of these steps. For example, we want to check whether 4x plus 5 is equal to 29. We want to solve this. We want to solve this. For example, if we want to solve this, 4x plus 5 is equal to 29. Let me share my screen. My Blackboard screen. 4x plus 29 is equal, and let's try to go through this. Let me share my Blackboard screen. All right, so we have 4x plus 5 equals to 29. So this is what we want to solve. 4x plus 5 is equal to 29. All right, so to solve this, so the first step here is to subtract 5 on both sides. So we have 4x plus 5 minus 5 is equal to 29 minus 5. So we subtract 5 on both sides. So we have 4x is equal to 5 minus 5 is 0. 29 minus 5 is 24. All right, so once we have the variable by itself, and the number also on the other side, as in this case, we can divide both sides by 4. And this 4 divides 4 once. So this is x is equal to 24 divided by 4 is 6. All right, so to check whether our solution is correct, we will substitute back 6 in place of x and check to see whether the left-hand side is equal to the right-hand side. So on the left-hand side, we have 4 times x, so 4 times 6 plus 5. 4 times 6 is 24, so this is 24 plus 5, which gives us 29. And on the right-hand side, we have 29. So we can tell that the left-hand side is equal to the right-hand side, because we have 29 on both sides. So since we have 29 on both sides, we can confirm that x is equal to 6 is a solution of this linear equation. All right, let's go back to the slide. Let's go back to the slide again. Let me show about the slide again. All right. So that's how we check that our solution is correct. Let me run through another example. Let me go back to the blackboard. Let's quickly run through another example before we come back to the slide. So let me stop sharing and share again. All right, so suppose we have another example such as 6x plus 5 is equal to, let's say, 2x minus 2. Suppose we have an example such as this, right? So the first step is we can group the variables on one side, and we can group the numbers also on one side. So we'll have 6x. If we subtract 2x on both sides, minus 2x is equal to negative 2. And if we subtract 5 on both sides, so, okay, let me do it step by step. Let me not jump over any step. So we have 6x plus 5. So let's subtract 5 from both sides. It's equal to 2x minus 2 minus 5. So we have 6x, 5 minus 5 is 0. So 6x is equal to 2x minus 2 minus 5 is minus 7. All right, so at this point, we can subtract 2x on both sides. So we have 6x minus 2x is equal to 2x minus 2x minus 7. So 6x minus 2x is 4x. So 4x is equal to 2x minus 2x is 0. So we have negative 7. All right, so once we have the x by itself, and we have the numbers also on the other side, we can divide both sides by 4. If we divide both sides by 4, then we have 4 divides 4 once. So we have x is equal to negative 7 divided by 4. All right, so we can check whether the solution is correct or wrong by substituting this value on the right-hand side and on the left-hand side, and check to see whether we get the same number or the same result on both sides. All right, so on the left-hand side, we have 6x plus 5. So 6 and x is negative 7. X is negative 7. X is negative 7 divided by 4 plus 5. All right, so this gives us 6 times negative 7 divided by 4 is 6 times negative 7 is negative 42 divided by 4. So this is negative 42 divided by 4 plus 5. All right, so if we find the LCM here, the LCM here is 20. You know, 5 is the same as 5 divided by 1. So the LCM for 4 and 1 is actually 4, not 20. So the LCM here is 4. 4 divides 4 times. 4 divides 4 once times negative 42. So we have negative 42. 4 divides 1 4 times. So 4 times 5 is 20. So this is plus 20. So this gives us negative 42 plus 20 is negative 22 divided by 4. All right, so let's also check on the right-hand side to see whether we get negative 22 divided by 4. So on the right-hand side, we have 2x minus 2, right? And as we saw, the x value that we are checking for is negative 7 divided by 4. So here is 2 negative 7 divided by 4 minus 2. So this is 2 times negative 7. It's negative 14. So we have negative 14 divided by 4 minus 2. All right, so the LCM here, 2 is the same as 2 divided by 1. So the LCM here is 4. 4 divides 4 one time. 1 times negative 14 is negative 14. 4 divides 1 4 times, and 4 times this 2. So it gives us negative 8. So this equals to negative 22 divided by 4. All right, so we are seeing that the left-hand side is the same as the right-hand side. They are both negative 22 divided by 4. It's equal to negative 22 divided by 4. So we see that x is equal to minus 7 divided by 4 is a solution. It's a solution to this linear equation. All right. Well, let me share my slide again. All right. All right. Some of the steps that we take in solving a linear equation involves we simplify the algebraic expression on each side by removing grouping symbols. We collect the variables on one side, like we put all the x variables on one side and all the numbers or the constant terms. Numbers are the same as the constant terms. We put all of them also on one side, and we isolate the variable that we solve. And once we solve, we have to check that our solution is correct by checking the proposed solution in the original equation. So once we have a solution, we check that our solution is correct by substituting checking what we get for evaluating the left-hand side, compared to evaluating the right-hand side by substituting the value of x in the equation. If both sides match, then we can confirm that our solution is correct. All right, so let's go through this example. X minus 4 divided by 2. Let me go to my blackboard. So this is an example of a rational equation. When you have fractions like as with x minus 2 divided by 4, it is x minus 3 divided by 4. We have x minus 3 divided by 4. Let me bear with me as I write down the problem. Is equal to 5 divided by 14. Is equal to 5 divided by 14. And minus x plus 5 divided by 7. Minus x plus 5 divided by 7. All right, so let me share the screen for my blackboard, and let's try to go over this solution. All right. So when we have a rational expression, an example with a rational expression such as this, the first thing that we do is to look for the LCM. And the LCM is a number that every number on the denominator can divide. So if we look at 4, 14, and 7, the LCM is 28. It's a number that all three can divide. Right? Let's see. 28 divided by 4 is 7. 28 divided by 14 is 2. And 28 divided by 7 is 4. So we can pick the LCM as equal to 28. And once we have the LCM, we multiply every term by 28. We have 28 times x minus 3 divided by 4 is equal to 28 times 5 divided by 40 minus x plus 5 divided by 7 times 28. All right, so 4 divides 28. 4 divides 28 7 times. So we have 7 times x minus 3 is equal to 14 divides 28 2 times is equal to 2 times 5 minus 7 divides 28 4 times, right? 7 divides 28 4 times. So we have 4 times x plus 5. All right, so now we try to expand the parentheses and group the x variables on one side and the numbers also on one side. So 7 times 3 is 7x minus 7 times negative 3, which is 21. And this is equal to 2 times 5, which is 10, minus 4 times x, which is 4x. And remember, there is a negative in front here. So negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. All right, so at this point, we can group the x variables on one side and also the numbers on one side. Let's group the x variables on the left-hand side. So we have 7x plus 4x is equal to 10 minus 20 and plus 21. Right, so now we have all the numbers on one side, all the x variables on one side. So 7x plus 4 is 11x, and this is equal to 10 minus 20 is negative 10, right? and negative 10 plus 21 is 11. So we have 11x is equal to 11. So if we divide both sides by 11, then we have x is equal to 1. All right, so we have x is equal to 1. So now we have to check if x is equal to 1 is a solution by evaluating, substituting x is equal to 1 on the left-hand side and on the right-hand side to check to see whether we get something equal on both sides. All right, so on the left-hand side, we have x minus 3 divided by 4. So we have on the left-hand side, we have x minus 3 divided by 4. So if x is equal to 1, then we have 1 minus 3 divided by 4, which is negative 2 divided by 4, or negative 1/2. Right? All right, so let's check the right-hand side also to see. So the right-hand side, we have 5 divided by 14. We have 5 divided by 14 minus x plus 5 divided by 7. X plus 5 divided by 7. X plus 5 divided by 7. All right, and x is 1. So this is 5 divided by 14 minus 1 plus 5 divided by 7. All right, so this becomes 5 divided by 14 minus 1 plus 5, which is 6 divided by 7. All right, and the LCM for these two is 14. 14 divides 14 once, and 1 times 5 is 5. 7 divides 14 2 times, and 2 times 6 is 12. So 5 minus 12. So this gives us negative 7 divided by 14, which is also the same as negative 1/2. So we can tell that the left-hand side is equal to the right-hand side. They are both negative 1/2. All right, so we can confirm that x is equal to 1 is a solution to this linear equation. All right, let me share my slide again. Stop sharing here and share my slide again. All right. All right, so yeah, so we confirmed x is equal to 1 is a solution. Let's look at another example where we have the variable in the denominator. So this is 5 divided by 2x is equal to, let me first write down, let me first write this down before, just bear with me for a second. Okay. Just bear with me for a second. Just bear with me for a second as I open my Blackboard again. All right. All right. So we have 5 divided by 2x. And is equal to 17 divided by 18. And minus 1 divided by 3x. All right, so let me share my blackboard again. All right, so we have another rational equation again, but this time we see that the variable is in the denominator. All right, so the key thing to note here is that if x is equal to 0, we'll see that we will have 5 divided by 2 times 0, which will be 5 divided by 0. And on this, at the same time, if x is equal to 0, the 1 divided by 3x would become 1 divided by 3 times 0, which is 1 divided by 0, which is undefined. All right, so right away, we can say that the solution excludes x is equal to 0. X cannot be 0, or similarly, or equivalently, the solution excludes x is equal to 0. X is equal to 0 cannot be part of the solution, because if it does, then we have an undefined, we have a division by 0, which is undefined. All right, so the LCM for 2x, 18x, and 3x is 18. So we can multiply, it's 18x rather. So the LCM, what can divide both 2x, 18, and 3x is 18x. So LCM is equal to 18x. All right, so we will multiply